So we're on page 120, topic 21, and we're going to be looking at two things in this video. We're going to look at how we can analyze the discriminant b squared minus 4ac and determine the number of x-intercepts that the parabola has. That's the first part of what we're going to do. And the second part, we're going to look at the application of the quadratic equation to a quote-unquote word problem. Instead of just being an equation, we're going to apply it to a problem concerning a soccer ball. So let's go and look at determining the kinds of x-intercepts that we may have in a parabola. And in order to do that, we have to analyze the discriminant. The discriminant is the value of b squared minus 4ac. So we're going to see that there are four cases. Case 1a and 1b are where the discriminant is greater than 0. In other words, b squared minus 4ac is greater than 0. And in this case, the answer, the roots will either be two rational or two irrational roots. In other words, the numbers concerning those will either be rational or irrational if b squared minus 4ac is greater than 0. So if it's equal to 0, we're going to say there's one root, and if it's less than 0, in other words, if it's a negative number, if b squared minus 4ac works out to a negative number, we're going to see there's no x-intercept, or the graph does not cross the x-axis. So let's take a look at case 1a. Example is if y equals x squared minus 6x plus 5. In this case, a is 1, the coefficient of x squared, b is minus 6, and c is 5. So if we calculate b squared minus 4ac, we get minus 6 squared, which is 36, minus 4a is 1, and c is 5. So 4 times 5 is 20, 36 minus 20 is 16. 16 happens to be a perfect square. So the x-intercepts are we find by setting the y value to 0 right here, and then factoring. And if you factor this, you can see that the factors are going to be x minus 5, x minus 1. X times x gives me x squared. The inner is minus 5x, the minus is minus x. If I sum them, I get minus 6x. The minus 5 times the minus 1 gives me plus 5, which is the last term. So therefore, the solution, if this is 0, and don't forget, if you're looking for the x-intercept along the x-axis, y equals 0. So we set it equals 0, x equals 5 and 1. These are two rational numbers. Rational numbers, you may remember, terminate or repeat. So like 5, there's nothing after the number 5. There's nothing after the number 1. These are what we call rational numbers. So now, case 1b, and if we take this equation here, it looks a little complicated, but when you look at it and you understand what I'm going through, you'll find it easier to follow. Excuse me. For this equation, a is 1, b is root 3 plus root 2, that's this term right here, and c is root 6. So b squared minus 4ac is root 3 plus root 2 squared minus 4. A is 1 and c is the root of 6. So if we take this and square it, first times first is going to give me the 3. The last times the last is going to give me 2. And the inner is going to be root 3 plus root 2. And we're going to have that twice. Excuse me. Let me go over that again. The inner term is going to be root 6, and the outer term is going to be root 6, because you're going to multiply root 2 times root 3, both inner and outer, so that gives you root 6. Since they both give you the same thing, you get 2 root 6 here. And so we have minus 4 root 6, which is here. So let me go over it again. First times the first gives me this. Last times the last gives me that. The inner and the outer sum to 2 root 6, and then I have minus 4 root 6. If I simplify this, 3 plus 2 becomes 5, plus 2 root 6 minus 4 root 6 becomes minus 2 root 6. This works out approximately to 0.1. And you can see b squared minus 4ac is greater than 0, but it's not a perfect square. That's case 1b. 1a was a case where b squared minus 4ac was greater than 0, but it equaled a perfect square. Now, to get the intercepts, again, we set y equal to 0 for this equation. So I set the y here equal to 0. And now I factor, and I get x plus root 3, x plus root 2. Notice x times x gives me x squared. Root 3 times root 2 gives me the root of 6. The inner term is root 3x, and the outer term is root 2x, and so when I sum those, I get this. I get root 3 plus root 2x, or this term right here is exactly the same. So now if I product of these two numbers is 0, if I solve this in this bracket, I get x is equal to the minus root 3, which is approximately equal to minus 1.7320, and there's a lot of numbers here which don't repeat or don't terminate. The numbers keep on going. Same thing, x plus root 2, x comes out to be minus root of 2. The root of 2 is 14142, and there are no numbers here. Numbers keep on going. So the numbers don't terminate and they don't repeat. You can review topic 1 for more information on this, both rational and irrational numbers. So the difference between 1a and 1b is that they both cases b squared minus 4ac is greater than 0. In one case, the two rational, the b squared minus 4ac must be a perfect square. In two irrational, it's not a perfect square, and but it must be greater than 0. So those are the first two cases. Now the third case 2 is where b squared minus 4ac is equal to 0. So an example of this is x squared plus 6x plus 9. So b squared is 6 squared, that's this one here. 6, b is 6, 6 squared, b squared, minus 4, ac, a is 1, that's the coefficient of x squared, c is 9. So you can see 36 minus 4 times 9. 4 times 9 is 36. It equals 0. So when b squared minus 4ac equals 0, we only have one root. We can show that if we set y equal to 0 in this equation here. Set the y equal to 0 and factor. We get x plus 3. X plus 3 equals 0. And so x equals minus 3. There's only one solution, and it's a rational number because there's no, it's minus 3.000. There There are no numbers after the decimal. One rational solution right here. This only crosses the x-axis at one point. Now, case 3 is where b squared minus 4ac is less than 0. If you go back up, that was this one where it's negative. Okay, so if we take this as an example, 2x squared minus 8x plus 9, okay, b squared is 64, 8 squared minus 4ac, 4 times 2 times 9. Here's a and here's c. So 2 times 9 is 18, 4 times 18 is 72, 64 minus 72 is minus 8. So if b squared is minus 4ac is negative, there's no x-intercept. And this should read b squared. I'm going to correct that right now. I'm just going to write this. So this should be small error there. So since b squared minus 4ac is less than 0, in other words, negative, then there's no roots. And you can see over here, this does not cross the x-axis, so there are no roots. Okay, so now let's go to example 7, which is the application of a quadratic equation. And in this case, we're told that a soccer ball is kicked from ground level on a parabolic path. In other words, on a path shaped like a parabola. And the equation is given by y equals minus 4x squared plus 20x, where y, this is the height. So this is the variable that is the height of the ball. And x is the seconds after which the ball is kicked. So anything on this represents the x. So the height depends on the time. Okay, if we change the time, we're going to change the value of y. So the first question is, how high is the ball 1 second after being kicked? So this means that we know, it says here x seconds, x is 1. If we replace the x with the 1 here, then we should get the height of the ball after 1 second, and that's part A. So we take the equation minus 4x squared plus 20x. We replace the x with a 1, and 1 squared is 1, so here we have minus 4. And 20 times 1 is 20, so minus 4 plus 20 is 16. So this is the height of the ball after 1 second. We took the time 1 second, and we want to calculate the ball. So the ball after 1 second after it's being kicked will be 16 meters high. The second part of the question is, when does the ball reach its maximum height? Well, if you realize that the coefficient of x squared is less than 0, so this is a frown, so we need to calculate the x value of the vertex. Now, if you look at the solution, if you look at the graph of this, you see the ball starts here, right here, and then gets kicked up. Here it is maybe after 1 second, and then it reaches a maximum because the graph is a frown, so it is a frown. So we're going to try and calculate when it reaches a maximum. And along here, you can see it reaches a maximum along the axis of symmetry. So if we know the x value, we know the time, and if we know the y value, we know the height. So what we're going to do is calculate the x value for the axis of symmetry, minus b over 2a. And so we have minus 20, b is 20, over 2 times a, and a is minus 4. So this is minus 20 over minus 8, which is 20 over 8. You divide 8 into 20, you get 2.5 seconds. So after 2.5 seconds, the ball reaches the maximum height. So here's along this axis, we have x. Here we have, which is the time, and here we have the height. This is the height, and this is the time. So here is 2.5, okay? And so at 2.5 seconds, it'll reach its maximum height. But what is that height? So what we do is we take the x value that we calculated from b, and we calculate the corresponding height by substituting it into this equation. So instead of x being 1, we're now going to put x equal to 2.5, because that's the time at which it reaches its maximum height. So minus 4 times 2.5 squared plus 20 times 2.5. 2.5 times 2.5 is 6.25, and we multiply it by minus 4, we get minus 25. So this first term becomes minus 25, and 20 times 2.5 becomes 50. So minus 25 plus 50 equals 25. So we now know the vertex is 2.5, which is the time at which it reaches the maximum height, and 25 is the height of the ball at this time. So if you look over here down in the graph, which is in the actual page, you can see that at 2.5 seconds, the height is 25. So the maximum height is reached along the axis of symmetry. The last part of the problem asks us, when will the ball land? Well, if the ball lands, then the height has to be 0. The ball will land when y equals 0. So we get minus 4x squared plus 20x equals 0. We get minus 4x times x minus 5 if we factor this. So we're factoring this. And the solutions are minus 4x equals 0, x equals 0, and x equals 5. Well, x equals 0 is just when the ball is kicked. So at time 0, that's when the ball is kicked. So we don't want that answer, we want this answer. So the ball will land after 5 seconds. And that's shown right here. In other words, y is 0 and x is 5. Over here is where we start. When at time 0, the ball hasn't been kicked. So the ball is kicked up in a parabolic shape. You can see that right here. Reaches its maximum height after 2.5 seconds. And if it reaches its maximum height after 2.5 seconds, you can see that it's going to be another 2.5 seconds for it to be 0, because it's symmetrical. So the distance from 0 to 2.5 is 2.5, and we add another 2.5 and we get 5. So this answer makes sense. But the key thing is to realize the ball is going up like this, reaches its maximum height, and then comes back down. And this is where when it reaches the ground after 5 seconds. So notice that you're not going to draw this graph below the x-axis. That's why this is here, because a ball will never have a negative height. So you're not going to continue this down here, because that means it falls below the ground. So this completes our discussion on page 120.